Namaskaram everyone. Welcome back to the 45th episode of our Master Unreal series. And in this episode, we are going to smooth out our entire interaction system work. So in the last few episodes of interaction system, I showed you how you can do the door interaction, how you can do the bench interaction, how you can push the boxes, cabinets, etc. So these three use cases that we have targeted, we have improved our interaction system a lot. And now it's time we bring all those three use cases on the same page so that our interaction system is consistent in all the three implementations, because we have been constantly upgrading it. We have been adding new events, new functions, new variables to handle the communication. And the reason of not doing everything optimal and perfect in the very first episode was because I wanted to show you how developers think, how they create their solutions, how they upgrade them, how do they upgrade or scale their systems to support different kind of interactions. In last few episodes, we have been juggling with many pieces, and now it's time we bring back everything at one place. So we will go back to our door and the bench interaction, and we will fix the issues that has appeared because of the new implementations or modifications we did in our system. So apart from this, I also wanted to show you that just doing simple how to do tutorials will not help in a production game, because there are a lot of edge cases that happens in your game which developers miss out when they are in the early stage. So we will go back and we will identify those edge cases, and then we will re-implement the door interaction, and we will fix sit on bench interaction as well. So if you haven't followed the series, and especially the interaction system episode, this tutorial will be little hard for you to follow. So I highly recommend you please check it out, this interaction system episodes, if you want to implement this final iteration of the stable version. So without wasting any time, let's get started. All right, so we are in the editor now. Let's have a look at the issues. So if I play, the door is in locked position, and now if I open, my hands are like very bad. This is because of the effectors that we have applied. So we have to disable the IK for the door opening animation. Let's have a look at the second thing. If the door is locked and I kick, it opens up. That means there has to be a check which should not allow door to open when you double tap to kick it. Another thing is that if I make the door open by going in the B is locked, make it false, play again, and now if I go and open the door and kick, see, it was opening and I just kicked. So the door was opening in the front and I was able to kick. So the kick should only be allowed in the first few fraction of seconds. If we have reached to the handle, then the kick should not be allowed. Another thing is, this is the front of the door. So if the door is opening outwards, then you should only be able to kick it from this side, right? So that logic is also not there. Another thing that I want you to notice is that when you press E and you try to move, you are able to move. You should not be rotating or moving your character at all when you are playing the animation montage. That means we have to restrict the movement keys input as well when you are performing this animation. So we need an option in the interface. So this is a demonstration how fixing things or implementing simple stuff to achieve one objective spoils the other one. So that's the reason I decided to redo this single door, and more importantly, we have finally came to a stable version of our interaction system. So this is a good time to re-implement these last two interaction use cases. And I'll keep this single door for now, and I'll name this classroom door handle and this one as classroom single door. Okay, and I'll create folder, call it classroom door, and I'll move these meshes inside this. Now let's create a blueprint class, type actor b underscore single door base. So this class is going to allow you to create any type of door with any type of design. Right now it's like this. Maybe the handle can be placed here or sit slightly upward, or the design of the door is different. So in that case, you do not want to copy all the stuff from this blueprint to this blueprint. So we are going to create this base blueprint and we are going to inherit the child classes of different doors. So I'll show you, and those doors can also have different lock system. They can implement their own way of opening or locking or unlocking. So keeping all the things modular and avoiding the duplication of your logic. So let's open this up. Also in this episode, I'll show you another way of detecting the front or back. So far, we have been using the function to determine whether you are standing in the back or in the front. This time I'm going to show you how you can also use box collider, which is also a common approach in these kind of use cases. So first let's add the door mesh. I'll open the classroom door and drag this in the scene roots. And as always, the facing direction should be in the right. So let's first add a scene component in the same hierarchy, and I'll rename this to door, and then I'll grab it, move it inside, and I'll rotate this. Let's select this, press E, and then rotate it like this. Okay, now if you press W, so now the facing direction is this one, which is something you should follow. So if you have observed this in your third person character, your character is also facing in this. All right, cool. So we'll go back to single door base. Now we have it. I'll compile. Another agenda of doing this episode again is to show you how you can implement the interactable functionality for any use case. So this is a full-fledged flow. I'll go in the class settings. I have to make it interactable. So I'll go for BLI underscore interactable. And now we have all the functions that you should implement to make something interactable. So let's hit compile, save all, go in the event graph. So the first thing that character does is check whether it is available to interact or not. So I will add a variable. B is allowed to interact. So we will get this is allowed to interact and we will pass it. So if this is true, that means it is allowed. Great. Now we hit compile, and this is allowed to interact should be true by default, because when you spawn the actor in the world, it should be allowed by default. Now let's move on to the interact, which is called based on your tap system. So in our case, the door has two functionalities. One is single tap, second is the double tap. So when you press single tap, we check if the door is locked or not. And if it is locked, then you just perform the try opening animation, and if it is unlocked, then you open the door, and if you press the action key again, then we are going to kick the door. So there are two taps involved. So I'll add a switch here. So we will say starting index should be 1, and then we should add 2 pins. So if it's a single tap, that means this is the first time someone is trying to interact. When I say first time, that means it's the initiation of the interaction. So in that case, we will save this instigator, which is the player, into a variable so that we don't have to pass it in the events. So I'll right click, promote this to a variable and call it player. Remember, you should only do this in that first tap. The reason I'm saying is because when you press the tap again, it will be going in the 2. So if we do this before, then you will reinitialize the player, which is not a good thing. So we will save the reference of player in the first tab. Then we would like to have the skeletal mesh of the player. So for this, we are going to use the function that we created in the BLI kinematics. So I'm going to use this and call get skeletal mesh. And this is going to give me the mesh. And I'm going to save it into a variable as well. And I will call it player mesh, or let's call it player sk mesh. Once this is done, we will call the single tap event. Now see, single tap means when you are pressing the E for the first time. Now if the door is locked, then in that case you will try to open, but if it has a lock attached to it and if you have the key, then you have to perform the key animation, that the key goes inside, then it rotates, then the lock opens, then you pull the ledge, then you open the door. So all that logic has to be done in the first tap. So based on the lock status, you define how the single tap is going to work. So in the base blueprint, we assume that there is no lock, it's just a simple door which can be locked. So I'll add a custom event and I'll call this. So this is the default functionality that we are going to code in this base class. But if a door has a lock, then they can override this functionality. So we will keep it lightweight. When I say lightweight, that means you should not attach anything that is more than required in the single tap. I'll show you. So let's first call the single tap. Okay. And we will say it is implemented because we have the single tap and double tap implemented for this door. And for the second, we will go for event graph again, call custom event, double tap and compile. Go back to interact and call the double tap here. Because remember, if you are pressing the double tap, then it's the same player, it's the same mesh. We do not need to save. But if it's a new one, then they will be starting from one all over again, and you can store their reference in the variables. Great. And we will say it is implemented as well. But if it's a third, fourth, fifth tap count, then we will say it is not implemented. So we will let it be false. All right. And for the hold interact, there is no such thing. So we will leave it false. And let's delete this hold interact, which I added accidentally. So the first thing that we have to do in the single tab is to call the on interact, which makes the is allowed to interact to false so that no other player can interact with the door till the interaction of this active player is done. Now we would like to detect from which direction you are doing the interaction. So for this we will go back to viewport and we will add two box colliders. If you come in contact, we will save your position. So we will create two box colliders in the default scene root. Go for box collision and name it front detector, duplicate it and rename it to back detector. Great. Now it's about positioning them. Let's assign the material. So I'll go for metal base gray 3. So this is our front side. I'll get this front detector. I'll position it 54.7, something I already figured out, minus 72. And your character should be colliding with this. And then we go for back, which should be somewhere around minus 49, and y should be minus 68. Okay. Now you might be wondering why I'm crossing the door's edge and detecting here, because you are not going to stand precisely in the front. Sometimes you might be standing somewhere near here. So let's cover that small delta or at the error zone. Now this is going to tell us. So I will compile. Okay. And then I'll go in the front and back detectors and scroll down, and I'll go for on component begin overlap. And then we will do the same for the front. So these two will be fired when you come in the contact. So now we do not want to detect everyone. We just want to detect the player. So we will go for a branch node. We will check whether this actor has a tag called player. Only if it's a player, then we will update the position. And I'll save all, compile, duplicate this one and connect it here as well. So remember, in the third person character under the tags of third person, you have this player. If you don't, just add it. So this will distinguish whether this is a player or something else. If this is so, then we will save the value. I'll create another variable. B is overlapped with front. Okay. So this is a back detector. So we will set it to false, which means it is in the back. All right. Is overlap with front means you are at the front side. So only when you are colliding with the front detector, we will set it to true. Otherwise, we will consider you are standing at the back. Now, when the interaction begins, the single tap will be the first thing that you will be calling. So when you will call the single tap, we have to call this on interact so that the interaction is disabled for all the other players. Let's delete these three nodes. We don't need them. And when the first interaction is begin, we need to store in which direction you are standing. So we'll create another variable. B is standing at front. So we will update this here. And the value we are going to retrieve from the begin overlap. Now you might be wondering why we are not using the same thing. The reason is when you open the door, you might get a little ahead, and your overlap with this back detector or the front detector will happen again. And we do not want to update this position again because the interaction is not yet finished. Another thing that might come to your mind is, why not just disable the detection if the interaction is in progress? If we do that, then once you will come in contact with the detector, the overlap will not set this. And now once the interaction is over, this will not be fired again unless you move away from this detector and come back to it. Remember, begin overlap means when you come into the contact for the first time. But when you come in the contact, your condition did not allow to set it and this thing is over. So when the interaction is set to allowed again, it will not update this. You have to move away and come back, which is not something we want. So we will keep updating our variable based on the overlapping, but we will only update the variable standing at front when the interaction is just begun. Okay, so that it is carried in the entire tapping system or other logic. Great. This will make more sense once we will implement the logic if you are new. Let's go for single tap now. When you do the single tap, first we would like to call the on interact, which means someone has interacted. So there are certain things that we have to do. From the call function, we will call the on interact, which is this on interact. And the instigator is not required, so we'll leave it. Once these two variables are updated, we would like to prepare our player so that it can position itself on the correct place so that animation plays perfectly. If I add a skeletal mesh and use a animation asset and select the SWAT soldier and go for, let's say, a door, lock door check. Let's do this. So you want to position your character exactly somewhere here so that it grabs the handle correctly, right? So we need to store that position. So first thing, I'll delete this skeletal mesh. This is something we have already done in the very first episode of the interaction system. So I'll not explain this again. I'll just tell you the coordinates and everything. So I'll go in this door handle and I'll set this height to 15, a little at the top so that my hand reaches there. Again, you can use IK factors, but I don't think in this case I need it. So I'll go simple. So I'll just move my handle a little up. Great. So we'll go back to event graph. And now we would like to prepare our player. That means position it and do all the stuff. So I'll create another custom event. I'll call it prepare player. Now we would like to position the player first. So I'll create a function, call it position player. And the function that we created in the last episode of box push, we will use the function called position actor to scene transform. Now I can tell this function where to position the character, what is that transform and all that. So I'll go and create 4 scene components, one for trying to open the door, that is the door lock animation. If I go in the characters, mannequins, animations, actions, I already shared these animations with you. So this is a lock door check. It can be performed from front and back. So these 2 locations we need, and then opening the door from front or back, which is again 2 more locations we need to save. So I'll go back to my single door base blueprints and I'll add, by selecting this default scene route, I'll add 4 scene components by duplicating. First should be locked front position. Then I'll copy this name and I'll paste it here and I'll rename the front to back. Then we will go for open front position. Then we will go for close front position. Okay. So we would like to position the character so that the animation plays out correctly so that the hands are aligning with the handle. Great. Now I'll tell you the values directly because I have already told you how you can do this in the first episode of interaction. Oh, this should be, sorry, this should be open back. My bad. So the open back, let's do this. -84, -35. Then we have the open front, 84, which is in the same line, just negative, and we will come here, it will become +84. And this should be -89 because the handle is there. And the character must be looking in this direction. So we will rotate this right vector, that is the X, in this direction. So I'll go for 180 degrees. Now you can get its rotation and you can apply the same rotation on the player so that player looks towards the door. This one is okay because it is looking, but in this case it was not. So that's the reason we did 180 degrees. Then we need to do for locked case. So for locked back, we will go for -49, -68. And for the locked front, we'll go for 54.7, -72.6. Again, these values can be updated based on your door in that door's blueprints that we will inherit from this base. Compile. All right, so we have everything. We will go back to position player. And now here you can decide which one to pick. So first of all, who is the target actor that we have to position is the player itself. So we will get the player reference and we'll pass it here. Then we will go for a select node. This will decide which one to go for. Is it front or is it back? So we will get this standing at front. So if it is front, then this branch will be followed. I'll go for a select node again because if you are standing at front, then what is the situation of the door? Is it locked or is it unlocked? So we will create another variable, b is locked, and we will compile it. It's okay. By default, we'll let it be false here and we'll get this is locked. So if it is locked, then I have to get the locked front position because this is the front pin. And if it is not locked, then I'll get open front position. And now I'll just duplicate this for the back side. I'll connect it here, locked back and open back, bring it here, connect this and this, compile. Good, we have everything. Now we need the actor here. Remember, we have to rotate the character in the direction of the door. So I'll get this, get rotation, the relative rotation, split it and get the Z. That's the reason we set the Z to 180 degrees in this case. Oh, we also have to do for locked front. So let's do 180 degree here as well. Okay. Don't forget this, locked front 180 degrees. All right. So our player will be positioned and now we can return. If you open this, we first move the player to the selective position. Then we disable the free look and the controller's rotation. That means you should not be able to look around so that you kick or open the door in that direction. If we allow free look, then your character will rotate and then the animation will play in the wrong direction. Another thing that I wanted you to recall is that in the blueprints, this move to functionality is implemented. This will be calling the on player ready. Remember, I told you in the last episode, this is a asynchronous function, which means it will take a fraction of milliseconds to position the character at that place. So we have to wait till the character is positioned. Then only we will notify the interactable that the further actions can be taken. So for this, once this is completed, we will call this on player ready and then the single tap will start. So I'll go back to single door base. I'll go back in the event graph and I have on player ready. Okay, so this will be called once the player is positioned. But first let's take it up and in the prepare player, I'll position the player first. Once this is done, remember you can open it from both the side, but our animation is only for the one side. So we have to mirror the animation so that it uses his left hand. So here you will use your left hand, here you will use the right hand, but we do not have animations for both. So that's the reason we enabled mirroring, which we also did in the second interaction episode. So please do check it out if you haven't seen that. I'll directly do the stuff. So first let's get the skeletal mesh. So this is the player skeletal mesh. I'll get the animation instance that is attached. That is ABP base in our case. And I'll set the animation tag. And the tag was ABP mirror so that it mirrors the animation. If you want me to go there and give you a quick recap, mannequins, animations, ABP base, we have an interface update set animation tag. Yeah. So when you pass ABP mirror, we were enabling the mirroring. And if we go in the animation graph, you can see we were using mirror data table to mirror the animation of the left and the right side. Okay. So we'll go back. Whether we have to mirror or not is decided by whether we are standing at front or not. So if you are standing at front, we have to do the mirroring because our animation is for the back. Great. You are on track. And now we have to disable the IK so that our hands and all that doesn't twist. So I'll go for R and update IK effectors. And actually, let's save the instance of this as well. I'll break this. I'll promote it to a variable player anim instance. Remember, storing all this is not allocating a new memory for all the player components and all that. They are just storing the reference. That means a pointer, which is very negligible in terms of size. It is better to save rather than calling it every time you do something in the animation side. So it's better to cache it. So I'll just go here and let's not do this thing here. I'll first go in the interact and I'll do it here. So I'll create a sequence node. First thing is to save the player and save its skeletal mesh. Once the skeletal mesh is saved, and let's get the instigator from the variables, not the actor, from the function, the F sign. Connect it here, not looking good. Then we will store the animation instance. So get the player's skeletal mesh, get its animation instance, and save it in the player anim instance. Remember, it's not assigning a new memory, it's just storing the reference. Then we will go for the single tap. Okay, compile. Let's go back to our errors. Get the instance, pass it here, duplicate this, pass it here. And we will disable the IK. So compile. Now, once this is done, the position player will launch the positioning and we will be getting this on player ready from the player. So first I would like to know whether the door is locked or not, because based on that, I will choose my animation. I'll put it here. I'll go for a branch node. I'll check whether the door is locked or not. So if the door is locked, then we will try to open it. We will play that animation. So I'll go for play montage and the skeletal mesh is this one. Now we have already created the montage in the episode. Montage is the locked door check montage. We will use that. And if it's not locked, we will play the opening animation. So we will go for open door outwards montage. Now when the animation is completed, we will call on interaction completed. So on interaction over, that is part of this actor. And then we will call on interaction interrupted if it is interrupted. So this is for the locked scenario. Okay, so let's implement this over and interrupt. So on interaction over, on interaction interrupted, and we will call our player on interaction interrupted from the BLI receiver. Okay, and we will duplicate this and we'll call on interaction over, on interact over, I'm sorry, and this should be in the interruption, my bad, and add our new door, architecture door, single door base. So now when the single tap is executed, first we will call on interact, then we'll call prepare the player. So let's call the prepare player here. Now it will position, it will set the mirroring, it will disable the IK, and then it will play the montage. And I'll select this B is locked variable and I'll set it to true because we want to test this first. And then prepare player will call the position player. Okay, we need to finish this up. The source actor, which has to be notified back by the player, is this single door itself. So I'll get the reference of self and connect this here. And I want to disable the free look and I do not want to use the controller's rotation. So compile and play, press E, and you see it tries to open the door. And I try to press WASD keys, you can see it's trying to move. So we have to disable the movement. For this, we will go back to our BLIs, and in the BLIs kinematics, we will rename this should use controller rotation to should allow movement, and we will consider all the properties there. So should allow movements, or you can say configure movements, that would be a better name. So one is your use controller rotation, second is your disable the free look, third is allow movements. Okay, now hit compile, go to third person character and disconnect this. This should be use controller rotation. We will create a variable be allow free movements, and we will set it. So let's go for a sequence node, break this one too, and let me remove my print string. Then we go for allow movement. Okay, compile, and we will go back to single door base, and we will open this up. We will correct this one as well, use controller rotation, and the allow movement is something we will accept in the input. So get allow movements and connect this here. Okay, compile, go back to single door base, and we will say not allow the movement. And now we can go back to third person, and in the input action that is responsible for movement inputs, we will extend the graph, and we will apply a branch node here and get the allow free movement and connect it here. So only if the free movement is allowed, then you should move, otherwise not. And by default, this allow free movement should be set to true. If I play, I can press E. Now you can see I'm not able to move even if I press the keys. Okay, and let's go back to our single door base. I think I made a mistake, that is I did not connected the actor, so I'll connect it here. And let's apply a print string so that we can keep track. Connect it here, connect it here. And if I play, you will see you are not getting any log even if you are touching the boxes. So for this, go to a third person character, make sure this is set to block the third person character, world dynamic. Okay, in the on interaction over, we have to allow the interaction again just for temporary testing. So in both the cases, we will allow the interaction again. And I was not able to move. So for this, we have to go in the interaction manager of our blueprints. And here I have to fix this configure movement as well. So I'll first remove it. First, we will say allow the free movement, use the controller's rotation. So this is required so that you get back to your default status. Compile. Okay, so this was for trying to open the door that is locked. Now we will go back in the logic. Now here we have to play the open animation, door opening animation. So for this, and now you can duplicate this. So on completion and on interruption. Now we will set this is locked to false. And in the animation, we have this animation montage, right? And we can name this open door. So this is the only notification that we are going to get. So when we are going to receive this, we are going to start opening the door. So once the door opening animation has begun, we do not want to allow the kick, right? So this is the logic of double tap. So assuming that this will work out fine, but let's first cover the use case, then we will apply the animation work. So when this notify begin is fired, that means the door will start opening. Now there is no going back. So that means we have to track. So what we will do, we'll create another variable, b double tap is allowed. So by default, double tap is allowed. But if the door is open and you have successfully reached to a point where the door has started opening, then there is no way you can kick. So first we will check at what side you are standing. So for this, I'll go for a sequence node. So for now, we will not allow kicking from any side if the door is started moving. So first thing we are going to do is set this double tap allowed to false. By default, it will be true. And then we will start playing the timeline for opening the door, which we will do a few minutes later. So once this is done, the double tap event can still be called. So we have to apply this check whether the double tap is allowed or not. And also remember that this prepare player can be called by anyone. So we only want to prepare the player for the first tap. In the second tap, it will be a kick. So it doesn't matter where he is standing. But even if it gets called, then this prepare player will call the on player ready. That means we should not allow this event to be called again if it's not the first step. So what I will do is add a branch node again. I have to make sure that no developer of mine or even me by chance call this thing, and this is calling this one, and this should not play again. So this should be allowed only for the first tap. So what I'll do, I'll create another variable, call it tap count. This is very use case specific, okay? So we will set it to integer and we will check if this is equal to 1, then only you should process this. Just to avoid that uncertainty where you might accidentally call this entire thing again. So this should be called only when the tap count is 1. And we will set it when the on interact is fired, because this is only called when the single tap is performed. So I'll go for tap count. I will set it to first tap count. Okay. And here I will set the tap count to 2, because if this is successfully past this condition, that means it's the double tap that is going to be played. And there is one more thing. When the double tap happens, the montage will not be interrupted. Let's say this door opening is happening. Now this interruption can only happen when you play the animation montage, but you haven't played any one right now. So now we are about to play. So player's skeletal mesh, we will call play montage, and we are going to use kick animation. Again, the same thing, copy the on interaction over and interrupted. So goes here, goes here. And when the notification is sent, let's say open door, save, we will start playing out the timeline. But as soon as this montage starts, this animation which was opening will be interrupted and this will be called. So once this interruption is called, third person will be notified. It will call its interaction manager and it will reset the animation. It will allow its rotation, movement and everything. We do not want that. So like I said, the interruption can be from the external influence and the interruption can be from functionality. So if the interruption is coming from a functionality override, then we should not notify our character. So this is an internal thing. So we are going to save that ignore the previous interruption right before we play this montage to interrupt. So I'll create a variable b ignore previous or ignore single tap interrupt, and we will set it to boolean. See, these are the edge cases you have to keep in mind. So I'll set it right before I interrupt. I'll set it to true. Now once this fires, the interruption will be called. So I'll perform a check, single tap interrupt. So if ignore, then we are not going to call it. Only if it's set to false, we will call it. We will do the same thing for this. So instead, you can just plug this here and you can delete this one. And if you want, you can also plug this on top because this is the same thing. And you can delete this one. Okay, so compile and save all. Awesome. Now let's do the timelines quickly. So I'll create a timeline. And let's name this door opening. Okay, and we are going to play from start. And I've already showed you how you can create this timeline. So I'm going to save some time here. Let's add a float track, set it to 1.25. Again, please check out the door opening animation episode. I already showed you how you can calculate the length, how you can decide the number, how do you create the curve. So I'll speed this up. I'll add my first point, add 0, 0, add second, add 0.37, and the value will be 0.54. Add another key, 0.65, 0.68. Add two more keys. This one would be at 0.79, 0.93, and this key 1.25 and 0.92. Okay, so let's compile, go back to event graph, and now I need to update the door position. That is our actor this time, not the scene component. So go for a custom event, update actor yaw. Two things we want. One is the yaw and in which direction you are rotating. So I'll create two input pins. One is the direction, float, and the yaw. Go for float. Next up, we want the actor current rotation. So this is the current rotation of actor. We will split this, set the actor rotation. The X and Y will stay as it is. Only the Z will be taken from here. So we will multiply it because the value is from 0 to 1, which is a percentage of total 90, because we have to rotate it from 0 degree to 90 degrees, and in which direction is decided by the direction here. Okay, so you can make it beautiful by first going direction, then going yaw, and then I'll plug this Z here. Okay, and let's hit compile and call this update actor yaw. Let's open this and name this to yaw. Compile, go back, plug this yaw here, and the direction is decided by the float. So if you are standing at front, it will be, then we will go +1. If you are at the back, then we will go -1. So that's how we decide the direction. Play. And now if you try opening it from the back, it opens fine. And if you close and play again, go in the back, press E, it opens fine. Great. So we have the timeline working. Let's go for the kick animation as well. When we are notified, we want to play the timeline of this. So this is something you can copy from the old blueprint. You can go here and this is the door kick. Just copy it and paste it here. Play from start. And same thing, update actor yaw. The yaw goes here. The direction, select float. If you are standing at front, go for -1 and otherwise 1. Okay. And once the door is opened, in both the cases, we have to close the door again. So now this is okay for this situation, but you can rotate your door like this, like this. So in that case, these values will change. So for this, we have to store the default rotation of your door when you spawn the door in the game. So we will go at top, we will call events begin play. We will create default actor rotation and we'll go for rotator and we will set it once the game starts. So no matter what rotation you have kept, we will get it. So actor rotation, plug it here. This is saved. And also to rotate the door based on the placement. So we will go back here in the update actor yaw and I'll break this pin, I'll add it and I'll get this default actor rotation and we will add in this. Okay, so if it's at 90 degrees, it will add in 90. So if it is at 180, it will add in 180. Okay, compile. So now what you can do for testing is press W, duplicate this 4 times and rotate it in different ways like this one like this, and this one completely like this. Okay. And now in the position player, we were accessing the relative rotation. So instead we will access the world rotation. Okay, because this scene will also rotate, so we have to get the world rotation, not the relative, because the relative will not change. So get the world rotation, split it, plug it in Z, compile, play, and now if you try this gate, it works fine. If you try this one, this works fine. Okay, so before testing the double tap, we have to close the door again. So once the interaction is over or interrupted, we will close the door. So we only need to close the door if the door is not locked, right? And till our door is not closed, we will not allow the interaction again. So this means this cannot be set directly. First, we have to close the door, then we will allow the interaction. Till then, it will not allow. So in the completion, we will create a custom event first. That's our close door. And we are going to call this close door. And we will call this here as well. And now this closed door will wait for, let's say, 2.5 seconds, and then it will close. Once it is completed, it will allow. First, it will allow the interaction. So let's add a sequence node. Second thing it will do is get the default actor rotation and it will set it. But that will only happen if your door is not locked. So we will check if the door is not locked, then close the door. So set actor rotation. And this is the default one. So we will set it. Press E. This opens up, wait for 2.5 seconds, and this closes. You can kick. The speed of kicking is slow. Increase that by 1.5 seconds like we had earlier in the kick UE montage from double tap. If we play now, let's kick this door first. This opens up and it will close. Okay, try this one. It opens up and it closes. And if the door is locked, we have already tested. And now let's try that use case. We try to open the door and then we kick in middle. 1, 2. Nothing happened. So the kick will only work if you have pressed on time. Okay, so let's close this. All right, so we are done with the door. Let's go back to our bench that is in the architecture. Let's open this up. So this one has only the hold interaction functionality. If you press interact, nothing is implemented. If you open the hold interact, then we have the stuff. The only thing we would like to change is the position actor. We do not want to use this anymore. And we are going to remove this position actor from here. And we can delete this position actor. We have the on player ready. Let's open it up. So when you press the hold interact, we will call the on interact for the first time. And actually, let's break this connection here. I'll break this as well. So when you do the on interact, you will call position actor to scene transform directly because we don't have anything else. Target actor. Then this is the source scene. Then you want to disable the controller's rotation. You do not want to disable the free look because you want to have a look when you are sitting on the bench. You do not need to allow any movement. And the actor yaw is the position start. Get world rotation. Split this up, pass in Z. And the source actor is the bench itself. So get reference to self. Compile. It's okay. Once this is done, we will get the event on player ready. So what we will do, we will go here and we will connect this player. Okay, and let's move this entire logic somewhere here. Compile. So now I'll go to dummy map and I'll place my bench. Then I will duplicate this, rotate it in 4 directions, duplicate again, duplicate again. Okay, and let's go to viewport as well. We have to fix this. So we will rotate our bench in the facing direction, that is this one. So undo, select everything and press this rotation and then rotate it in minus 90 degrees. And I think we have to bring this little here. Position to start is fine. Compile, and the position to start, we have to make sure that the X is facing in this direction as usual. So we will rotate it by 90 degrees. And let's position it in the center. So let's revert it and let's fix the box. It should be here, and the position start, let's push it somewhere here. So we will set this position to 42 in X. Okay, that was the one that we had earlier. Let's hit compile, play, hold E, and we are able to sit. If I press W, I get up, and then I try on this one, hold E, I sit. If I press W, I get up. Try on this one, hold E, you sit, you can get up. Okay, this issue, remember this leg up? So we will go in the event graph, and we were calling this on interaction ended, and we were pushing the player. So what I'll do, I'll get the actor's location and we will add this. We have to now keep track of the direction in which we are facing, because as you saw in the map, the benches are in different directions, so the player will face different direction. So we have to get the forward vector. So where is my bench? Okay, so get the forward vector of our player. So get actor forward vector, and this is our actor. We will multiply. Again, to understand the concept of forward vector in detail and how it's used in interaction and in predictions, check out the cabinet push interaction episodes. I will multiply it by single precision. So the value was 25 units. So, and we will add it here. Okay. So it will only add in the direction in which we are facing. And instead of 25, you can keep it 35 so that it works out just fine. So if I play, hold E for 0.2 seconds and then I get up. Okay, I'm good. Now for that abrupt movement or rotation of the character, in the position actor to scene transform, we can provide an option of smooth. So we will open this up and we will say smooth over time. And we will call this a float. And in the move to, we will pass that. So what we will do, we will go to our BLI kinematics. In the move to, you can provide the smooth over time. So smooth over time, let it be float, compile, go to generic functions. Now get this. So get smooth over time and pass it here, compile. Now we can go to third person character and we will plug this here. So in case of our door, let's open the door base, prepare player. We are passing the position player. The smooth over time, let's set it to 0.01. Compile, go to the cabinet, open this up, and in the position character, we will set it to 0.01 again. But for our bench, we want little smooth. So 0.5, the position actor to scene transform. Now if you compile and play, go and hold E, you will see it will take its sweet time. Okay. And if you want, you can also take this for shortest rotation path from the input as well. But I like to keep it as it is. And the next thing that we want is to test our cabinet as well. So let's keep it here, duplicate it, duplicate again, duplicate again. And if I play, hold E for this one, and if I release, that means I'm interrupting. If I try that one, I'm still coming here. So that is the issue which is happening in the third person characters interaction manager. So I'll go in the blueprints, interaction manager. When you are interrupting, you are resetting the character setting, but you are not resetting the tap count and the current hit actor or anything. So you have to do this. I will remove this one and I'll connect it here. Now if I play, go here, hold E. If I interrupt and go to the another box, if I push, I'm able to push. If I interrupt, I can go to this one, hold E, and you can see I'm able to push. And let's push it all the way to the next and then release it. Go to the old one, hold E and push. It works fine. Okay, you can also try sitting on a bench now. Hold E for 0.2 seconds. You sit, you get up, and you can also open the door, push it or kick it, and you open the door again, you kick. Okay, and this is our first stable version of receiver, interactable, and the kinematics. Okay, so let's give a big save all, and in the next episode I'll show you how you can inherit a door from this base class to create a door with a ledge. So stay tuned, like the video, share it with your friends, subscribe to the channel, and if you haven't joined the Discord, please do find the link in the description and join to interact with other people, ask your doubts and queries, and if you have any confusion, feel free to reach out. And if you like my work and you want to support me, the Patreon link is in description. Please do reach out before buying any membership plan. So till then, take care and I'll see you in the next video.